The topic of our presentation is distribution of functions between operators in information systems. The fourth industrial revolution, on the one hand, reduced physical activity, but on the other hand, increased the intensity of activity. Emotional tension constantly increased. The problem is that in complex technological systems, the risk of accident increase. The probabilities of environmental problems are very high. Often the causes of accidents in such systems are human operator mistakes. This is not surprising. People work often in conditions of great tension and even stress. To ensure the reliability of a human operator, an ergonomic support system is needed. In modern computer systems, a large number of operators work at the same time in a single informational space. Tasks can enter the system at random times. In critical systems, requests must be executed very quickly and without errors. It is also very important to ensure the comfortable and safe work of people. To distribute functions and manage the work of people in computer systems, special operators manage work. The difficulty lies in the fact that it is necessary to take into account a large number of factors. Often operators manage work only on the basis of their own experience. Our task is to develop models and information technology that will help them make decisions about managing the activities of other people. To begin with, we analyzed what indicators should be taken into account. These indicators include the probability of error-free execution, the probability of timely execution, the functional state of the operators, and others. If we analyze the requirement that are typical for most control systems, we can understand that the task of distribution of functions is the task with several criteria. This is a multi-criteria optimization task. To quickly solve such problems, the operator manager needs a decision support system that can firstly predict the values of local indicators that characterize the efficiency of human-machine interaction and the working conditions of operators, and also choose the best option. The system should consist of monitoring some system, forecasting some system, and a decision-making subsystem. We must also take into account all the factors that affect the quality of activity: algorithms, working conditions, qualifications, functional state, motivation, etc. A large number of scientists are studying the optimization of human-machine interaction. Among the known theories, the functional structural theory is the most convenient. This theory uses a model called a functional network to describe the activities of a human operator. This is a very useful way of modeling, but we have great limitations in the application of this model. The main limitations are: there is no opportunity for fully automatic estimation of the reliability of the operator and fully automatic optimization, and we must provide such capabilities for our decision support system. To estimate the reliability of the activities of operators, typical functional structures have been identified. There are 22 such structures. Here you can see only some examples. To estimate the reliability of the operator's activity, it is necessary to carry out several stages of the functional network reduction. At the same time, it is necessary to find typical functional structures and use mathematical models to calculate reliability. Due to this, we developed a special computer program that allows us to estimate the reliability of activity. Here you can see examples of formal models for the real technological process. The program can conduct an automatic estimation of the reliability of activities. Here you can see an example of estimation process. And here are some results of estimation. In the case of a large number of options, an optimization problem should be posed and solved. If it is necessary to solve a multi-criteria problem, we suggest using the hierarchy analysis method developed by Thomas Saati. This method allows you to structure the problem, analyze the reliability and characteristics of all operators, and also allows you to take into account the importance of all criteria. We propose to use a flexible scale of preferences, which was proposed by Thomas Saati. Here we can see examples of how different operators can approach the evaluation of criteria importance: extreme pragmatic approach and extreme ergonomic approach. The convenience also lies in the fact that you can quickly get a single assessment for the quality of the option of distribution of functions. This allows the operator manager to quickly navigate and make decisions in critical situations. As a result, I want to say that a new method of multi-criteria distribution of functions between operators working in a single information space has been developed. And a result was tested in different management systems in industry, agriculture, and electronic learning. Thank you for your attention.